Hello everybody, this is Michael. In this video, we will talk about the state machine solution 01 analysis for FPGA sequence detector. Okay, so for the state machine solution, the first things we need to do is to analyze the status for the sequence detector. As we know, our detector target is 11011. Okay, 11011. So the first stator for every state machine, the first stator is always idle. We use S0 present idle state. Okay. Next state will be S1. Okay, the S1 means we already detected this bit. Okay, we detected this bit. So next will be S2. We detected this one and this one, and this one. And the next will be S3, 110, okay? Next is 1101, S4, S5, 11011, okay? In this stator means we already detected our target. So we will put the high level on this P. Okay, so this is all the stators we analyze for our stator machine solution. So next step, we need to analyze the relationship between all the stators. Okay, let's take a look at this table. Okay, this transition table. So the first part is the current state. This is the current state here. The next part will be input. The input will be 0 or 1, either 0, either 1. Okay. The output will be 0. Output is here. Input is here. Okay. So for the first current stator, of course, is S0, right? Is idle state. Okay. So if in the idle state, if our input equal to 0, of course, we will keep into the idle state. If the input is 1, so we will go S1 state. We will go into S1 state. At this moment, we will output 0. Because we only detect 1, right? So next state will be S1 state. Okay. When the S1 become to current state, we will check the input. So when the input is 0, it will become to 10. It will not match any status of any other status. So we will go back to idle state. Make it is like S0 idle state. We go back to idle state. If we get one input as 1, if we get our input as 1, so it will become to 1. So it is S2 state. So we go into the S2 state. Okay. At this moment, we still output the 0. we still output 0 because we only detect for the carrying state, for the S1 carrying state, we detect only 1. Okay, so we still output 0. We still output 0. Okay, so next, when the S2 become to carrying state, it means we already detect 1, 1. When the input is 0, when the input is 0, we will get 1, 1, 0. We will get 1, 1, 0, which means the next state will be S3. Okay, the next state will be S3. If here, if we get the input is 1, okay, you will see then the next 2 bit is 1, 1. Okay, so we keep into the S2 state. Okay, we keep into the S2 state. So for the current state S2, we still output 0. The current state is 1, 1. S2 is 1, 1. So we still output 0 level. Okay. Similarly, we can get the foreign state switch. So the current state is S3. When it's 0 coming, it will become 1, 1, 0, 0. Not match any others. So we go back to idle. We go back to idle. And next it will be 1, 1, 0, 1. Match S4. So we go to S4. Okay, the next state will be S4. Okay, so here for the carrying S3 state, it output 0. Similarly, we will get the S4. It will go S0, and the next is go to S5. And the output for the S4 is still 0. For the S5, if we get the input as 0, we go back to S0. And if the input is 1, we go back to S1. Okay, because the S5 already detect all the number, all the bits as 1, 1, 0, 1, 1. So we output 1 high level bit here. We output 1 high level bit here. Means we already detect our target. Okay. This part is current state. Okay. This part is the next state. The next state, according to different input, okay, according to different input, it will switch to which state, okay? It will switch to different state. This output is output the different value according to current state. According to current state. Okay, once we have the have this table, have this transition table, we can coding our state machine. Okay, so this is for this video. Next video we will do the coding and the simulation for the state machine solution. Okay, so this is Michael. See you next time.